Friends, from today we have started this series of the NCERT. In this series we cover the different chapters of the NCERT, and first video will we start from the science, which will cover science and different concepts, and it will help in your revision in different types of examination like UPSC, PSC, SSC and other like competitive examinations. Now we will start the chapter matter. It is from the NCERT class 9. Now we will discuss what are the concept and different types of the term which is used in this lesson. So what is matter? We can say everything in this universe is made up of material that is known as matter, like stones, air, clouds, stars, plants, water. All these things are made up of matter. All these things occupy space and have mass. They occupy a definite space and have a mass, or they have both mass and volume. Physical nature of the matter. What are the physical nature of the matter? First property, if you can say that matter is made up of particles. Matter has tiny billions and millions of particles in it. You can see the solid, liquid and air. Generally three types of the and three states of the matter exist in the nature. There is also fourth and fifth matter that we will discuss later. First we will discuss about solid, liquid and air. If we see the example and we can understood something from this example also. Take some salt and add in water and stir. You can see then when you add a salt, it will slowly dissolve, and when you stir, it completely and evenly distributed in the whole water. And I can ask you that where the salt goes. Then you may tell that salt is dissolved in water, but salt has occupied the space between the particles of the water. There must be a space between the particles of the water where the salt occupy the space. Shows that particles of the salt get into the spaces between the particles of the water. Even a small amount of salt, if you add in water, make the water taste salty. Why? Because there must be millions of teeny particles in just one crystal of salt, which keep on dividing in smaller and smaller particles. So, the size of these teeny particles is very small and can be divided into smaller and smaller particles. Second property of the matter is particles of the matter have a space between them. There must be a space between the particles of the matter. If we see the earlier example of the salt and the water, the salt particles occupy the space between the particle of the water. It shows that particles of the matter have a space between them. Third property is particles of the matter are continuously moving. The particles of the matter are in continuous state of motion. See the example in a beaker which is full of water. If we add sugar in it and then apply a heat, the kinetic energy of the particles of the matter gain and it will dissolve in the water fast. Now we came to a new term Diffusion. What is diffusion? It is a intermixing of the particles of two different types of the matter on their own. In this example, if we add sugar in the glass of water, then it will take more time to dissolve a sugar in the glass of water evenly and thoroughly. And if we apply a heat, then this diffusion process increases. On heating, the rate of the diffusion increases. Particles possess kinetic energy, and this kinetic energy gain when we apply heat. Fourth property is particles of the matter attract each other. Try breaking a iron nail, a piece of chalk, a rubber band by hammering, cutting or stretching. In which three substances particles are held together with the greater force? You definitely say that the iron nail requires much greater force to break in comparison to the piece of chalk and a rubber band. What it shows that the particles of the iron nail, a piece of chalk and rubber band must attract each other. This force hold this matter in a definite shape and definite volume. States of matter. There are three states of matter: solid, liquid, gas. Solid. Solid has definite shape, distinct boundaries, and fixed volume. It has negligible compressibility. When we apply a pressure on a solid, very little compression takes place. It may break under force, but it is difficult to change their shape. In liquid, no fixed shape but have a fixed volume. They take the shape of the container in which they are kept. Liquid flow and change their shape. So it is comes in the category of a fluid. Gas. It has neither a fixed shape nor a volume. Highly compressible. It is compressed and stored in the LPG cylinders and CNG cylinders and used in home and businesses. Now, how matter changes its state: solid into liquid, liquid into gas, and vice versa. If we take a ice cube in a beaker and apply a heat, it changes its state into water. Further application of heat leads to the different state, that is water vapor. Now we came to a new term, latent heat. What is latent heat? It is a heat energy absorbed by the particles of the matter when changing its state. Take the example of the ice cube. When we apply a heat from the burner, that heat is absorbed by the particles of the ice cube, which is used to convert the ice cube into the different state, that is water, and that heat which used by the ice cube particles is known as latent heat. It is generally not shown in the system, and latent means hidden. It is a hidden heat which is absorbed by the particles of the ice cube, so it is known as latent heat. On increasing the temperature of the solid or liquid, kinetic energy of the particles increases. If the kinetic energy of the particles of the matter is greater than the force of attraction between the particles, then the state of the matter changes to the different state, that is solid into liquid and liquid into gas. In earlier slide, we have seen the effect of the temperature on the states of the matter. Now in this slide, we will see the effect of the change of the pressure. If we apply a pressure on a different states of matter, what is the effect? We have taken the example of a gas. It is put in this cylinder and from piston we apply the pressure. When we apply a little pressure, it is compressed a little. When we apply a greater pressure, it is more compressed. And you can see the particles of the gases came closer in comparison to the first cylinder. Applying pressure and reducing temperature can liquefy gases. By applying a pressure or reducing a temperature can liquefy a gases, it means that gases will convert into liquid state. LPG cylinder and CNG cylinder. In it, gas is compressed into liquid state so that large quantity is stored in cylinder. As gases in comparison to the liquid occupy much larger volume, so it is generally compressed and liquefied and stored in a small cylinders. Factors affecting rate of the evaporation. If we increase the surface area, more surface area leads to the more evaporation. High temperature leads to high evaporation. High humidity leads to low evaporation. Why it is so? Because humid air have very less space between their particles, as the space between the humid air is occupied already by the particles of the water, which leaves very less space available for the evaporated particles. Increase in wind speed leads to increase in evaporation because every time new air mass is available around the evaporated particles. In this last slide, we will see how evaporation causes cooling. Particles gain energy from the surrounding and evaporate and leave the surrounding cooler. How it happens? We take an example. Pour some acetone nail polish remover on your palm. The particles of this nail polish remover gain energy from your palm and evaporate, causing your palm cooler. It takes some energy from your palm and it leads to cooler palm in comparison to the earlier. In this chart, you see the different states of matter and the process through which it changes its state into solid, liquid, gas, and vice versa. Sublimation is a process in which solid is directly converted into gas and gas is directly converted into solid. Latent heat of fusion. It is a amount of heat energy required to change 1 kg of the solid into liquid at its melting point. It is a heat which is used by the solid particles to change into liquid state. Remember that latent heat of fusion is always used by the solid particles to change its state into the liquid. And what is that temperature or heat? It is a temperature which is equal to its melting point. Different solid has different melting points. Latent heat of vaporization. This latent of heat of the vaporization, it is used by a liquid to change into the gaseous state. So, it is the amount of heat energy required to change 1 kg of the liquid to gas at atmospheric pressure at its boiling point. See, there is some difference of the temperature which is used in the latent heat of the fusion and latent heat of the vaporization. Latent heat of the fusion is used by the solid particles to change its state into liquid and temperature is equal to its melting point. and in case of latent heat of vaporization, it is used by the liquid to change its state into gas, and temperature is equal to its boiling point. In this video, it is all. Thank you.